Okay, so here we are with molar mass calculations. So we mentioned these really briefly early on, and this is essentially how we work out the mass of 1 mole of a compound. Okay, so a little bit of symbols and units. So generally we use the symbol MR, so M subscript R for molar mass, okay, and it has the unit of grams per mole. Okay, so this can be written as grams mole to the -1, remembering that -1 for indices laws essentially means 1 over. So we've got grams times 1 over mole, which means that we essentially get grams per mole. So you can write it either in the grams/mole way, which is perfectly acceptable, or the g mole to the -1 nomenclature, which is also an acceptable way to write this unit. But anytime that we quote a molar mass, we must include a unit. Okay, remember that our AR, our relative atomic mass, didn't have units or could be given the unit AMU, but it is critical to remember that our molar mass or relative molar mass has units of grams per mole. Okay, so the molar mass of an element is essentially the mass of 1 mole. Okay, so if you were remembering back to when we talked about this in terms of a dozen, this would be the mass of 1 dozen. So if we had 12 50-gram eggs, okay, so if we had 50-gram eggs and we wanted to talk about 1 dozen, the molar mass is the mass of 1 mole, so this is like talking about a dozen mass. Okay, so the mass of 1 dozen would be equal to 50 times 12, which would be equal to 600 grams per dozen. We could sort of write it like that. Okay, but we're actually talking about mole. So essentially, what we're looking at now is the mass in grams of 1 mole of substance. So how much would 1 mole of water be, or 1 mole of carbon? Okay, and we said in the definition of a mole that it was based on the number of atoms in 12 grams. So if we took that 6.02 times 10 to the 23 and multiplied it by the mass of 1 atom of carbon, we would come up to 12 grams. So the molar mass of carbon is 12 grams per mole. Okay, so the molar mass is 12 grams per mole of carbon. Okay, so remembering that the relative isotopic mass of carbon-12 is 12. Okay, so if we expand on that to be any substance, so compound or element, it's going to be the relative isotopic mass, okay, or the relative atomic or molecular mass of that substance expressed in grams per mole. So if we look at oxygen, you may remember that oxygen had a relative atomic mass of 16. Okay, and the molar mass of oxygen then will actually be equal to 16 grams per mole. Okay, and if you remember correctly, this actually comes off our periodic table. Okay, so we can just look up the relative atomic masses from the periodic table, which means if we take the same value from our periodic table and add this grams per mole to it, we have the molar mass of that element, which is another particularly handy thing. So if we want to get the molar mass of a compound or a molecule where we've got more than 1 atom combined, we do the same thing as what we did with relative atomic mass. We basically had to add all the masses together of the constituent elements, so the bits that make it up. In the case of water, we could say that the relative molar mass of water, again, like we did before, using the brackets to put around it and say what we're talking about. So we read this as the relative molecular mass or relative molar mass of water, and then we would take it as 2 lots of hydrogen, because I have 2 hydrogens here, okay, plus the relative molar mass of oxygen. When we take the values off our periodic table, hydrogen is 1, oxygen is 16, And when we add those together, we get 18 in total. So the relative molar mass of water is 18 grams per mole. So if we were to weigh out 18 grams of water, which would be 18 centimeters cubed, okay, because 1 centimeter cubed is equal to 1 gram for water, then it would actually contain 1 mole, or 6.02 times 10 to the 23 molecules of water. Okay, and we can see that this is exactly the same as the relative atomic mass of water, just no unit on this one here. Okay, this gives you the ability to do questions from page 16 all the way up until A to J. It should be pretty straightforward, okay? Remembering that we basically, when we want to find out the molar mass of something, we look up the component atoms. Okay, mass on the periodic table, and then add them together. Of course, remembering the unit. So let's have a look at a couple of quick examples before you have a go at these on your own. Okay, so if we wanted to work out the molar mass of, say, ammonia. Oops, let's get back here. So ammonia, which is NH3, okay, we would go to the periodic table and we would look up nitrogen, and we would find that nitrogen has a relative molar mass of 14. And then we would add 3 lots of hydrogen to it, which is 1. So then all together, we would have 17. Okay, and because it's a molar mass, we must give it the 17 grams per mole. Okay, if we were to do something like methane, again, we would have CH4. We would go to the periodic table. We would look up carbon, which would be 12, and then we would have 4 lots of hydrogen, which is 1. When we add those all together, we would have 16 grams per mole. And we just follow this for exactly the same process for regardless of what it is, even if it's something more complex like glucose, which is C6H12O6. We would look this up, and we would find that we had to have 6 times 12 plus 12 times 1 plus 6 times 16, and when we added all that up, we would get 180 grams per mole. Okay, so when we're looking for a molar mass, if we've been given the formula, we just need to go to our periodic table, add them all up, and then remember to write it with the unit added, and we're done. Okay, so now it's your turn to have a bit of practice, and I'll see you in class.